The Physiological Cascade, From Emotion to Inflammation and Metabolic Disease. Researched by Sachin Karnik, The Angel Wing, LLC. Abstract. The historical separation of psychiatric and somatic medicine has long obscured the profound biological interconnectivity between the mind and the body, creating an artificial dichotomy where mental health is treated in isolation from physical well-being. However, the emerging and rapidly evolving field of immunometabolism is dismantling these barriers, mapping the precise physiological pathways through which subjective emotional states are transduced into objective cellular pathology. This essay provides an exhaustive analysis of the physiological cascade outlined in the research presentation by the Angel Wing, LLC. It delineates the three critical interconnected stages of this pathogenic trajectory: the initial neuroendocrine dysregulation of the hypothalamic pituitary adrenal axis, triggered by emotional disorders; the subsequent systemic propagation of pro-inflammatory cytokines, known as the inflammatory bridge; and the final manifestation of metabolic dysregulation. This progression characterizes the insidious transition from chronic psychological stress to chronic physical disease, offering a unified theory of how emotional suffering becomes biological injury. Introduction. The psychosomatic interface. For much of medical history, the mind-body connection was relegated to the realm of philosophy, mysticism, or alternative medicine. Traditional Western allopathy viewed the central nervous system as distinct from the visceral organs, separated not only by the physical blood-brain barrier, but also by distinct clinical disciplines and diagnostic codes. The findings presented in the Physiological Cascade, From Emotion to Inflammation and Metabolic Disease, fundamentally challenge this reductionist view. They present a unified, systemic model of health, where emotional disorders are not merely mental events confined to the cranium, but are profound physiological stressors with body-wide repercussions. The central thesis of this research, rooted in the work of the Angel Wing, LLC, is that emotional disorders, specifically the potent combination of depression, anxiety, and chronic stress, act as primary biological triggers. They initiate a specific, quantifiable, and reproducible sequence of events that begins in the neural circuits of the brain, but concludes in the metabolic pathways of the liver, pancreas, vasculature, and adipose tissue. This cascade is mediated by inflammation, serving as the common soil, or biological currency in which both mental and metabolic pathologies take root. By deeply understanding this three-step progression, HPA axis dysregulation, increased inflammation, and metabolic dysregulation, clinicians and researchers gain the insight necessary to treat the patient as a holistic system, rather than a collection of isolated symptoms, moving from symptom management to root cause resolution. Phase 1. The neuroendocrine origin, HPA axis dysregulation. The cascade begins in the central nervous system, specifically within the limbic system, the brain's emotional command center. Under normal conditions, the human body responds to stress through a highly conserved, evolutionarily ancient neuroendocrine feedback loop, known as the hypothalamic pituitary adrenal HPA axis. This system is designed for acute survival, to rapidly mobilize resources in the face of immediate danger. When an individual perceives a threat, whether a physical reality, like a predator, or a psychological perception, such as chronic financial anxiety or social isolation, the amygdala signals the hypothalamus to release corticotropin-releasing hormone, CRH. This hormone travels a short distance to the pituitary gland, stimulating the massive release of adrenocorticotropic hormone, ACTH. ACTH then enters the general circulation and signals the adrenal cortex, located atop the kidneys, to secrete cortisol. Cortisol is the body's primary stress hormone, a glucocorticoid designed to mobilize glucose for energy, heighten alertness, and dampen non-essential functions, such as reproduction and the immune system, to prioritize immediate survival mechanisms. The research highlights a critical, pathological failure point in this system: HPA axis dysregulation. In healthy individuals, the HPA axis operates on a negative feedback loop. High levels of circulating cortisol bind to receptors in the hypothalamus and hippocampus, signaling the brain to stop producing CRH and ACTH. This off switch returns the body to homeostasis once the threat has passed. However, in states of chronic depression and anxiety, this delicate regulatory mechanism breaks down. The constant psychological activation keeps the HPA axis in a state of perpetual hyperarousal, or allostatic load, where the wear and tear on the body accumulates over time. The slide notes that this dysregulation is more evident when they occur together. The comorbidity of depression and anxiety creates a unique and devastating physiological storm. While depression is often characterized by a blunted, flattened, or erratic cortisol curve, a failure to mount a proper response, anxiety typically drives a hyperactive, exaggerated response. When these conditions coexist, they strip the HPA axis of its natural circadian rhythmicity. The result is a body bathed in cortisol, not in response to an acute solvable crisis, but as a chronic baseline state. Crucially, this chronic exposure leads to a phenomenon known as glucocorticoid resistance. Much like insulin resistance in diabetes, the glucocorticoid receptors on immune cells become desensitized to cortisol. Under normal circumstances, cortisol suppresses inflammation. However, when these receptors downregulate or stop listening to the cortisol signal, the immune system escapes inhibitory control. This paradox creates a dangerous biological milieu. The patient has high levels of stress hormones, which should suppress immunity, yet they simultaneously exhibit high levels of inflammation because the suppression mechanism has failed. Phase 2, the inflammatory bridge. The second stage of the cascade describes the translation of neuroendocrine dysfunction into active immune activation. This is the inflammatory bridge, a critical transition where psychological distress becomes a tangible immunological event. Due to the HPA axis dysregulation and subsequent glucocorticoid resistance described above, the immune system is no longer checked by the body's natural anti-inflammatory safeguards. The research identifies 3 specific biomarkers that define this phase, effectively measuring the temperature of this systemic physiological stress. 1. TNF-alpha, tumor necrosis factor alpha. This is a potent cell-signaling protein, cytokine, involved in systemic inflammation. Originally identified for its role in inducing the necrosis of tumor cells, TNF-alpha is a master regulator of the immune response. In the context of chronic stress, it acts as a siren, signaling widespread alarm and recruiting other immune cells to a battle that isn't happening, damaging healthy tissue in the process. 2. IL-6, interleukin-6. This cytokine acts as a critical messenger, traveling from the site of stress or infection to the liver. In the context of emotional disorders, IL-6 is often secreted by immune cells in response to the danger signals generated by the stressed nervous system. It serves as a relay runner, carrying the message of distress from the brain and the periphery to the metabolic organs. 3. CRP, C-reactive protein. CRP is an acute phase protein synthesized by the liver specifically in response to stimulation by IL-6. It is a non-specific marker of inflammation. While often used by cardiologists to assess heart attack risk, elevated CRP in this context represents the liver's metabolic response to the brain's emotional state. This triad represents a state of sterile inflammation. Unlike inflammation caused by a pathogen, virus, bacteria, or physical trauma, this immune response is triggered by endogenous stress signals, a fight or flight response turned inward. The chronically stressed brain signals danger, and the immune system responds by preparing the body for potential injury, anticipating a physical attack that never comes. Macrophages and other immune cells begin to churn out TNF-alpha and IL-6 continuously. These cytokines do not remain local. They permeate the general circulation, creating a systemic pro-inflammatory environment. IL-6, in particular, acts as an endocrine disruptor, stimulating the liver to synthesize CRP. Elevated CRP is a widely recognized clinical marker for cardiovascular risk, yet its roots often lie in this psychoneuroimmunological process. This stage represents the turning point where the pathology is no longer confined to the brain or the adrenal glands, but has become a systemic, blood-borne phenomenon affecting every organ system, altering the behavior of cells far removed from the central nervous system. Phase 3, metabolic dysregulation. The final stage of the cascade is the manifestation of hard physical disease. The research describes this as metabolic dysregulation, characterized by the severe disruption of lipid and glucose metabolism. This is where the long-term cost of the previous 2 stages, neuroendocrine exhaustion and chronic inflammation, becomes evident in the form of diagnosable metabolic syndrome. The mechanism of glucose disruption, diabetes risk. The pro-inflammatory cytokines discussed in Phase 2, particularly TNF-alpha, have a direct toxic effect on insulin signaling pathways. Insulin acts as the key that unlocks cells, specifically muscle and fat cells, to absorb glucose from the blood for energy. TNF-alpha interferes with the molecular machinery of this lock, specifically by phosphorylating the insulin receptor substrate 1, IRS1, at serine residues, rather than the tyrosine residues required for signal transmission. This biochemical alteration effectively jams the lock, inducing a state of cellular insulin resistance. Consequently, the pancreas must work overtime, secreting higher and higher levels of insulin, hyperinsulinemia, to overcome this resistance and keep blood sugar stable. Over time, the beta cells of the pancreas, the insulin factories, fatigue and fail. As a result, blood glucose levels rise, leading to the development of type 2 diabetes. The slide notes that this process contributes directly to the development of diabetes, underscoring that this is a mechanical, molecular consequence of inflammation, not just a behavioral correlation. For example, depressed people eat poorly. The stress itself changes how the body processes sugar,